Now let's do a minimizing length problem. Suppose I have two posts. One is 12 feet high and one is 28 feet high, and they're placed 30 feet apart. And they're being held in place by a wire. One wire that starts at the top of the 12-foot post, goes to a stake in the ground, and then it's connected to the top of the 28-foot post. Now for this problem, I'm going to put my origin at the base of the 12-foot post, and the distance from the base of the 12-foot post to the stake is x. If that is x, then the distance from the stake to the base of the 28-foot post is 30 minus x. Now, we're looking for x. That's what we're looking for here. Let's look at what equations we have. For the 12-foot post, I can see that I have an equation, y equals the distance from the top of the post to the stake, and that's 144 plus x squared. The next equation I have involves a 28-foot post, and that is z is the square root of 30 minus x squared plus 28 squared. Oh my goodness. Let me simplify z down a little bit, because that is a little ugly. If I multiply this out, it's x squared minus 60x plus 1,684. What other equations do we have? Well, I don't like w, but we'll use it anyway. Let's let w equal y plus z. Now, this is my primary equation, and these two are my secondary equations. That one and that one are the secondary equations. So the next step, I want to solve this for w. So w is, let's see, w is the square root of 144 plus x squared plus x squared minus 60x plus 1684. All right. Now the next thing I need to do is solve this. And by solving it means I need to take the derivative of w with respect to x. And this is a little ugly, I know that. So this is x. I'm going to simplify it. Divided by the square root of x squared plus 144 plus x minus 30 divided by the square root of x squared minus 60x plus 1684. Now we want to set this equal to 0. There's quite a bit of algebra here. What I'm going to do is move this over and cross multiply. So this is x times the square root of x squared minus 60x plus 1684 equals minus x minus 30 times the square root of x squared plus 144. Now I cannot solve this the way it is. I need to square the entire equation. And when I do that, this side over here, let me extend my page, I'm running out of room, becomes x squared times x squared minus 60x plus 1684 equals x minus 30 squared, if that negative sign goes away, times x squared plus 144. Now, I know you're going to be tempted to see if you can cross something out, but don't do that. Just multiply this whole mess out and collect like terms. Now, I'm going to do that with the magic of television. That's 640x squared plus 8640x minus 129,600 equals 0. Yuck. Let me factor this mess out. This is 320 times x minus 9 times 2x plus 45. So my two critical points were x equals 9 and x equals minus 45 halves. Now, this is a real problem, so this is not in the domain. And lo and behold, x equals 9 is in the domain. And you remember, our domain is what? We didn't set this out at the top. We have a closed interval here. It's from 0 to 30. So I need to check the 3 points. I need to find w at 0. And w at 0 is an ugly mess, but it's about 53.04. W at 9, when I plug 9 in, I get 50. And then the length at 30, the other endpoint, is 60.31. So I'm able to conclude that the minimum distance, or the minimum amount of wire I need, is 50 feet. All right. And I need to answer my question. And my question was, where do I place it? I place it at x equal 9 feet.